G'day, so we are continuing our videos about our topic soil science, and last time we looked at the different primary and secondary minerals that rocks are made out of and how they can change from one form to another based on whether they are put under heat or pressure or going under weathering and erosion and so on to change their form. So today we're looking at specifically weathering, how rocks are being broken down from a big piece of rock to smaller pieces and eventually becoming soil. So the weathering of rocks, it is the breaking up of the rock that are exposed to weather and on the surface of the earth. Okay, so usually when it comes to the surface, it can be weathered. Rocks can be weathered down if they are under soil layers, but usually it happens the quickest when they're on the surface of the soil, close to the atmosphere. So the importance of weathering, except for making soil, but it's important because it's the rock, the physical rock that's being broken down. So it forms your soil. Secondly, also it breaks up certain minerals, releasing minerals into the soil. That's important for all life, for vegetation and so on to grow. And then also different weathering processes cause chemicals in the rock minerals to be released into the soil. So it's important for the minerals, important for the chemicals to be released, and also for creating soil. Okay, so there are different types of weathering factors. The first type of rock weathering is by mechanical means. Okay, so this is the physical breakdown of rocks into smaller pieces. So there are four factors that has to do with mechanical weathering and what causes this. And the first one is temperature. Okay, so and over here is a beautiful picture of how temperature causes mechanical weathering. So during the day, the surface of the rocks becomes heated up and very hot. And as you may know from physical sciences, anything that's heated up, it expands. And when things usually cool down, it contracts. So when it heats up this rock, it expands, and during the night, the temperature goes down, and then this rock also contracts. So this causes friction within the rock. So then later on, joints start to form on the outer layers of this piece of rock, and it's also known as exfoliation. This kind of chipping away of the outside layers of the peeling away of the outside layers of the rock. Also, like ladies like to exfoliate their skin. It's just peeling away those outer and dead skin layers from the skin to make the skin look prettier. So don't know whether that makes the rock look any prettier, but it does make it smaller. So as you can see, fractures are starting to form, and then later on it becomes smaller as these fractures drop off from the rock later on, the broken pieces. So it becomes smaller rocks. So that's how temperature can cause this weathering. Water is also a thing. In the case of this rock is a real example. This rock had a small crack in it, I would guess from the top. And then as water flows into it at night in cold temperatures, it would start to freeze. And frozen water also exerts more pressure. It also expands to the outside. So as this expanding pressure of the frozen water pushes on the rock, on the inside of the rock, it pushes the rock to expand outside or to the outer limits of what it can. So then as soon as the day comes again, the water thaws and it starts to leak into the deeper made fissure. If it was like maybe just this length, the water expanded and it created a bigger crack. So then the water can reach the lower layers of the crack, and as soon as night comes, it expands again and creates a bigger crack and then leaks down to the next day when it's a bit hotter. So on until, like you see here, a huge fissure is formed within this piece of rock. So water has very powerful it's very powerful in changing soil and rocks and so on. It can exert a lot of pressure. So then also alternate wetting and drying of rock can also cause this mechanical weathering, as I've just explained. So it's temperature of water and then pressure as well. So when rocks are underneath the soil layers of the earth, a bit lower down closer to the earth's core, there's more pressure. The lower down you go underneath the soil, the pressure builds. So if some rocks are underneath the soil and it's used to all this pressure, and during the process of erosion or something happens that this rock is displaced or replaced closer to the surface where the pressure is less, it can also cause a rock to break open or be broken down into smaller pieces, because this change in pressure causes the physical change of the rock. Then lastly, wind can also, if there are loose areas, like in this case, the temperature caused the cracks in the rock, and there's these loose pieces of rock still on the outside of the bigger rock, wind can come and blow away the smaller pieces. And it can also be distributed among the rest of the soil. So wind also loosens its particles and blows them away. And all the same can happen if it rains and more water comes. The smaller pieces can also be washed away into the rest of the soil layers. Okay, so that's physical. Then chemical weathering, same thing, is also caused by three factors or three things. The first thing is called carbonation. So carbonation refers to carbon dioxide. So what happens here is that water combines with carbon dioxide to form carbonic acid. Anyways, H2CO3, carbonic acid, and what this causes is it reacts with the other chemicals like calcium and magnesium in the rocks, and then it creates or causes it to be able to dissolve in water. So as soon as carbonic acid reacts with the other minerals in the rocks, it allows those minerals that is the building blocks of the rock to be washed away if water comes. So then the rest, all those minerals washes away, and then we get something like this also with reaction with water. As soon as the water comes and it washes away, we can get caves. Where this was a solid piece of rock, now there's actually space open here as the water went through, and if there was carbon dioxide, it reacted and all the minerals washed away. Then there's also a process called hydrolysis, and this is when the rock or the minerals inside the rock also reacts with water, but what the water then does, it breaks down, the breakdown process, it breaks down the rock into smaller pieces. So for example, it can, silicates such as quartz, it can weather down and create something else. The minerals literally just washes away, or it creates smaller pieces of rock. Then thirdly, hydration. It is also a reaction of the rock with water, but in this case it builds up. So when certain minerals react with the water, it actually creates new rock to form. An example of this would be the mineral anhydrite. It is calcium sulfate. And also something with gypsum. Gypsum is used in the construction of industry and building of houses and so on. And we also use gypsum for pH regulation in the soil. But it can create new minerals or new type of rocks. Then something I forgot to mention here is oxidation. So the reaction with oxygen. Sorry, that's the fourth one. It occurs when oxygen combines with compound elements in rocks to form oxides. Okay, an example of this, you can see how red these rock samples are, is when oxygen reacts with minerals such as iron, and then this oxidation process happens, and then the color of the rocks turns red to show that the iron has been oxidized. Okay, so then with chemical reactions, we also have biological rock weathering. Okay, so biological has to do with living organisms. So it involves the breakdown of rocks and minerals by living organisms. So first example would be root growth. Here is a pretty picture of how the roots of a plant have actually distorted or change the shape of a rock, it's actually like choking the rock and breaking off smaller pieces as it tries to grow through the rock and around the rock. Then we also have things called pioneer plants over here, like your lichens. It's the most abundant plant. It's called pioneer plants. When a new ecosystem starts to form, they are the first plants to grow in any area. So if this area, this picture doesn't show, but if there was no soil around here, if everything was bedrock and rock, the lichens are the first plant types that try and look at all these fissures. They start to, their roots start to grow inside the small particles of the air spaces of the rock, and it starts to break down these bigger rocks, and eventually when they have broken down, it takes a long time, broken down all these rocks, soil starts to form, and then as soon as there is soil in this ecosystem or this area, larger plants can start to grow because then they have soil to actually grow. Okay. Then we have things called metabolic processes, and this usually refers to decomposition and respiration. So when carbon dioxide and water is released into the soil. And also when microorganisms come and they, like certain bacteria, and they also chemically break down certain minerals in the soil to create soils. So it's these biological creatures creating all those metabolic processes, carbon dioxide, water, and this everything creates soil as well. And then lastly, we have our burrowing animals. Well, here we have an example of a chipmunk. They can be something like dassies, moles, also earthworms and ants. And what they do is when they dig into the soil or dig into the rocks, not saying this one caused this fissure, but if he now goes and digs a little bit deeper into the rocks, he also can eventually lead to the creation of soil. They break down little particles of the rock. Then moving on to soil forming factors. Okay, so there are primarily 5 factors that can cause soil to form. So first of all is your parent material, and this is like your secondary or mineral rock, primary or secondary mineral rocks, and also whether it's igneous or that, all the 3 different types of rock. That is what you start with. Then things like topography also influences it. I'll go into more detail with each one. Topography, climate, your biological organisms, and also through time. Most of these takes a long time to evolve. The soil takes a long time to be created. Okay, so first of all, topography. Topography refers to the shape of the land and features of the landscape. So if we take this guy as an example, here's a bit of a slope. We have a soil area that's high up and a soil area that's lower down. So first of all, yes, looking at slope, you'll have poor soils along the side of this slope, because can you see with the dark layer of soil, there's not really a lot, because things like wind and rain and so on washes away most of these soil particles. So at the side of a slope, there's usually just bedrock. So the plants struggle to grow here. But on the tops and on the bottom of the slopes, there's usually a larger deposition of soil, so the plants can grow easier. Also with great filtration and so on, so water stays here. But with a slope, the water just drains down, goes downwards. So there's not enough water here anyway for the plants to grow, despite there also being too much bedrock for the plants to resisting the plants to grow. Okay, so also in flat areas, flat here and flat down here, there's also less weathering and erosion, so the soil will also stay where it is. It's less likely for the soil to be washed away. So then also altitude is another factor to look at. And the altitude is the height above sea level. How far away are you? And it has to do with the temperature as well. So the climate at high altitudes up here is usually more extreme than at low temperature. So your temperature would be higher here than down here. And some plants can't handle the heat, so they grow better at lower temperatures. So the slope also causes, or the altitude determines the temperature that determines the temperature that the soil will be exposed to. And thirdly is the aspect. So the aspect over here has to do with which area of the slope is exposed to the sun. So in South Africa, in the southern hemisphere, the north-facing, let's go the north-facing slope, gets more sunlight than the south-facing slope. So what this means is that more evaporation takes place from the north-facing slopes, and this means that less runoff of water from the north-facing slope. So less weathering of water takes place here. So more evaporation of water on this side, and it's much hotter. More water will be able to accumulate here, so it's better for crops to grow on this side where the sun is not always shining. But it is important to have sunlight because, remember, without sunlight we don't have photosynthesis. So the aspect does change what can grow where and how the soil structure looks like of the soil. Then we look at climate factors, climate and your temperature and so on, mostly to do with, climate. So first of all is your rainfall. So rainfall is the first factor. Very high rainfall leads to extensive leaching. So let's take the tropics where there is a lot of rainfall. It says 100 to 200 centimeter a year. It can be more sometimes. Definitely more. So this dark patch here shows how deeply the water has infiltrated into the soil. So in the tropics, there's a lot of soil water. In places like the desert, there's not a lot of soil water. There's a thin layer here at the top, if you can see, but in temperate regions is usually the best. So there's enough water for all the plants to grow. And in the Arctic, even though it's ice, it's kind of like a desert. Not much can grow there, despite there being so cold and so many ice there. So the rain is one thing, then also your temperature. The temperature will also also determine how much water is in the soil because the temperature evaporates soil water. So in general, chemical reactions take place faster at higher temperatures as well. So chemical weathering of rocks and so on will take place at a higher rate or a quicker rate in the desert than, say, the tropics. Chemical weathering of the soil will be much slower in the tropics. It is hot here, but not as hot as in the deserts. So then lastly is wind. Wind also is a climate factor. It increases the evaporation of water from the upper layers of soil. So if there is usually more wind in the desert, very hot winds, so then also evaporates more water. Then we look at biological factors. So it has to do with your soil organisms. First of all, we look at vegetation. So everything at the soil, the top soil layer, basically, all the plants there. So vegetation covering the soil prevents soil erosion, so it holds the sand soil in place. Then also plant roots can also loosen the soil. Here we see as the roots go into the soil, it loosens up all the particles and it makes way for gases and water also to infiltrate the soil. Then we look at microorganisms such as bacteria and fungi. They are there because they decompose organic matter and they put back minerals and things into the soil. Then also animals, larger animals. Mesofauna also refers to large animals, so these two will actually refers to the same thing. So this will be your earthworms, your larger organisms, and something like your mole. They also create these larger pore spaces and areas inside the soil. Things like earthworms are actually very important because they literally eat the soil and then their feces also enriches the soil. And as they burrow, making these tunnels in the soil, they can also replace or move soil particles. If they start here and maybe go to another area, they actually can take some soil particles with them. So it's like they take it from here and deposit it in another area. So they also don't want to say till the soil, but they also change the soil structure by changing where what lies. Then humans are also a biological factor. like farmers, when we remove vegetation, if we see weeds and we remove it, we actually change the soil structure because the roots go out and everything go out, and we change the way the soil and everything looked. And also by tillage, when farmers want to make place or areas for crops, they till the soil and change everything. They can change it to the deeper layers of the soil, deep down, depending on how deep down they till or the furrows go. So they change the soil. Then lastly, parent material, also very important. So your parent material can be the specific minerals that is being used to form the soil. Usually it's from bedrock, so your bedrock would be something like the metamorphic rocks. Okay, so the two factors that have to do with parent material is geology and mineralogy. So geology is specifically the type of rock, the bedrock, or whatever rock you start with to make the soil. So that is then the parent material, and then as organic matter and mineral fragments and things are being added, humus as well, and as the plant growth comes, they actually break down all the different pieces of the bedrock to form soil. And this also changes the composition of the soil, and then you get soil. So everything is made from this parent material, which is the bedrock, or the physical rock that's being started with. So geology has to do with that type of bedrock. If you get maybe sandy soils, they are formed from rocks that contain quartz. So then you'd know the parent material will have to be quartz, or a type of quartz like granite or sandstone, if the end product was something that is a bit sandy. If the end product was a bit something that looks clayish or feels like clay, it could have been formed from shale or dolomite bedrock. So the end product usually tells you what the parent material was. And then mineralogy has to do with the type of minerals inside. So, and also the texture. So if the bed or the parent material was coarse, it feels rough, then your end product, the soil, will also be a bit rough, okay, based on the minerals that are inside. Then our last factor is time. So soil forms faster in tropical climates than in drier temperate climates. So the hotter and the wetter it is, the quicker sand or different soils can form. So basically what you have is like in the previous picture, parent rock is weathered and fragments move upwards. So you start with the bedrock and then the soil moves as this is being weathered down and turns into soil. So this is your immature soil, young soil, has organic matter and humus is being added. And then as soon as you have plants as well, you start to have your mature soil, because now here when the plant roots start to infiltrate the soil and you have more carbon dioxide and more water and everything is at the levels it should be, you have your mature soil. And everything happens over a long piece of time, and generally in the southern hemisphere where we are or in South Africa, for 1 centimeter of soil, so as soon as 1 centimeter of soil has formed here, it takes about 300 years. So it doesn't happen overnight. It takes 300 years for 1 centimeter of soil to form. Okay, so I'm going to stop here and finish this unit in the next video.